Question 4, Part B. The diagram shows two spinners which are spun simultaneously. Each of the three outcomes on the first spinner are equally likely, and each of the four outcomes on the second spinner are equally likely. Part 1. What is the probability that both spinners stop on the same number? We can think of this situation as a two-stage probability experiment because we're combining the results of two spinners to form each possible outcome. Now we can use a tree diagram or a two-way table to show the sample space. If you recall, the sample space is the set of all possible outcomes of this experiment. I'm going to use a two-way table in this solution to list the sample space. Now the rows of the two-way table represent the result of spinner 1, and the columns of the table represent the result of spinner 2. Now from spinner 1, we can obtain a 1, a 2, or a 3, and from spinner 2, we can obtain a 1, a 3, a 5, or a 7. Combining those two results to form each outcome, we have 1, 1, 1, 3, 1, 5, all the way through to 3, 7, and it gives us 12 outcomes in total. Now, two of those outcomes show the same number, so 1, 1 and 3, 3. So out of those 12 outcomes, 2 are the favoured outcomes. So the probability of obtaining the same number on both spinners is 2 over 12, which simplifies to 1 over 6. Part 2. What is the probability that at least one of the spinners stops on a 3? Referring to the two-way table that was drawn in Part 1, so that's this table here, 6 of the outcomes contain at least one 3. So 1, 2, 3, 4, 5, and 6. So the probability of at least one 3 showing on a spinner is equal to 6 over 12, which simplifies to 1 over 2.